Hi, today we want to consider quadratic inequality and how we can find the true set of quadratic inequality. Now the question is, what is quadratic inequality? Quadratic inequality is any quadratic expression involving one variable having the inequality symbol or sign. So we can have quadratic expression like x squared plus 5x plus 4. Now this is quadratic expression involving one variable. When this quadratic expression involves inequality symbol, that is either greater than or equal to, less than or equal to 0, the expression becomes what we call the quadratic inequality. So we can have a typical example to be equal to, let's say, 2x squared minus 5x plus 2 is greater than 0. This is the standard example of quadratic inequality. So today we want to consider how we can find the true set of some quadratic inequalities. That is what we'll be doing today. But before we do that, we have four main types or four main forms of quadratic inequalities, which we'll be going through. The first one will be of the form ax squared plus bx plus c being greater than or equal to 0. The second type will be ax squared plus bx plus c is greater than 0. The third form will be ax squared plus bx plus c will be less than or equal to 0. And then the last type is going to be ax squared plus bx plus c is less than 0. These are the four types that we'll be going through, but in this lesson we'll be considering only the first type. Okay, so in this lesson our attention is going to be on the ax squared plus bx plus c is greater than or equal to 0. Let's consider this example under this type. Let's say you have x squared minus 2x minus 3 is greater than or equal to 0. How can we find the true set of this particular quadratic inequality? Yes, the true set. Now for you to find the true set, what we have to do is this quadratic expression, we have to try factorizing that or solve for that. So we'll try factorizing this using the normal quadratic factorization approach. Okay, so we take our constant, that is negative 3, we use that to multiply the coefficient of the square term, and that is positive 1. So negative 3 times positive 1 will give us negative 3. We find two numbers in which when we multiply we get the negative 3, but when we add we get a coefficient of x, that is the negative 2. So in this case the two numbers that will work for us is going to be negative 3 and then positive 1, because negative 3 times 1 is going to give us negative 3, but negative 3 plus 1 is going to give us negative 2, and that is the coefficient of the x term. Okay, so we are going to have our x squared minus 3x plus we have our 1x because of the positive 1. Okay, so minus 3, that is our third term here, being greater than or equal to 0. So we factorize the first two terms. We are going to have our x minus 3 and take the next two terms. The common factor there is positive 1. So 1, we have x minus 3 being greater than or equal to 0. So this is going to give us x minus 3. We have x plus 1 being greater than or equal to 0. Now at this point, we change the inequality symbol there. We equate it to 0, then we solve for the x, because we are going to use the two values that will be derived from this quadratic inequality. So we are going to have the x minus 3 and then the x plus 1 being equal to 0. We take each linear factor, we equate it to 0. So we're going to get x minus 3 being equal to 0. And then we have the x plus 1 being equal to 0. Okay. Now for the x minus 3 being equal to 0, we are going to get x to be equal to 3. And then the x plus 1 being equal to 0, that is going to give us x being equal to negative 1. Now we have these two values, x being equal to 3 and x being equal to negative 1. Does that mean that that is the true set? No. How do we find the true set? Now, finding the true set of quadratic inequality, we have two approaches. We have the graphical approach, and then we have the testing approach using the number line. We are going to consider the two approaches and how possible best you can adapt to one, either the graphical approach or the number line approach. Okay. Now we are going to start with the graphical approach. Okay. The quadratic expression was x squared minus 2x minus 3 being greater than or equal to 0. And we solve for the two values, or we solve for the quadratic expression, that is x squared minus 2x minus 3. And we had x to be equal to 3 and x to be equal to negative 1. Okay. Now for the graphical approach, we are going to draw the quadratic expression there. Now, without you going through the process of drawing quadratic expression or graphing quadratic expression, you can use the coefficient of the x squared to determine the shape of the curve that you are going to get when you draw the quadratic expression. Anytime the coefficient of the square term is positive, when you draw the quadratic expression, the shape is going to be like this. That is the U shape. This is when the coefficient of the x, that is the a, is greater than 0. And anytime the coefficient of the x squared, that is the a, is negative, the shape is going to be like this. And that is when a is less than 0. Okay. Now in this case, the expression given, the coefficient of x squared was positive 1 here. So it means that the shape of this quadratic expression, when we graph that, is going to be of this form, U shape. Okay. So this is not drawn to scale. We are going to draw that. So we are going to have, let's say this is XY plane. And let's assume that we have our positive 3 somewhere here. And then we have our negative 1 also here. This is not drawn to scale. And since we know that when we graph this quadratic expression, it's going to be of this form, that is U shape. So let's assume that when we graph that, it's going to be like this. Okay, something like that. This is not drawn to scale. So our curve is going to be like this. Now, after drawing the curve, the next thing you have to consider is the inequality sign. In this case, the inequality sign that we are having is greater than or equal to. So anytime you are having a greater than or equal to, in this case, we are going to shade the upper part of the curve, or the part of the curve which is above the x-axis. In this case, the part of the curve which is above the x-axis, we have this side, because this part is the part of the curve which is above the x-axis, and also we have this part also. These parts are part of the quadratic curve which is above the x-axis. Now, since we have shaded this part, what you have to do is you have to trace it to the x-axis. So it's going to be like this. And we can shade this up to positive infinity. Likewise, this side. We trace this to the x-axis. And we can shade this up to the negative infinity. Now the question is, what inequality can define the x values from this -1 up to negative infinity? Don't forget, the part of the curve which is above the x-axis was what we have shaded. But I've used this blue color to shade. So we started from this -1, this point, and started shading up to this side. And as I said, we can shade up to negative infinity. We are moving from -1 up to negative infinity. So the arrow is like this, from -1 up to negative infinity. As I said, we can shade up to infinity. If we have to extend this curve, we can continue shading. We can continue shading up to infinity. So it is from -1 up to negative infinity. Therefore, the inequality that will be defining all the x values from the -1 up to the negative infinity is going to be x is less than or equal to the x value that is here, that is -1. We started from -1 here, you shade up to negative infinity. So this inequality here is going to define that. Therefore, for this side, we'll be having x less than or equal to -1. You come to this side. Once again, you started shading from this point up to this side, and this can continue up to positive infinity. We can shade up to positive infinity. But you're tracing it to the x-axis. It means that we start shading from, or this x value that is here, that is the +3, is inclusive. The +3 is inclusive. And we are going to include that, all because from the original inequality, it was greater than or equal to this equal to sign. It's trying to tell you have to include the +3 here. And we are shading up to positive infinity. So the arrow is pointing to this direction. Therefore, you are going to have your x greater than or equal to. Look at the arrow. The tip was pointing to this direction. Therefore, the inequality symbol that you have to use here, the tip should point toward a positive direction. So it's going to be x is greater than or equal to this particular value that is here, and that is 3. So the truth set is going to be x is such that your x is less than or equal to -1, that is this particular one, or x is greater than or equal to +3, that is this particular one. This is the truth set of this particular quadratic inequality using the graphical approach. Let's try and use the testing approach using the number line. Okay, so we are having x squared minus 2x minus 3 being greater than or equal to 0. And when we solved, we had x being equal to -1 and x being equal to +3. So let's draw our number line, which is not drawn to scale. So let's say we have a 0 here. Let's say we have 1, we have 2, we have 3, yeah, -1, and -2, yeah. Okay, now as it stands like this, we have 3 main parts. Let's use the values here, the -1 and then a +3. So we have one part here, and we have another part here. So we have this part, we have this part, and then we have this part. We want to try and test something here. Don't forget that the quadratic expression, when we factorized, we had x plus 1 and then x minus 3 being greater than or equal to 0. Okay. Now, as it stands like this on this number line, these 3 main parts, we are going to test them as to which one satisfy this particular expression here. We can use this particular one too, the main one, but we want to use the factorized form because that will be easier for us. We start with the -1. When x is equal to -1, what is going to happen? So now, when x is equal to -1, we substitute -1 into this particular factorized expression here. So we are going to have -1 plus 1. We have -1 minus 3 is greater than or equal to 0. Let's analyze this, whether this statement is true. Now, -1 plus 1 will give us 0. 0 times whatever expression or whatever number that we're going to get in this bracket is also going to give us 0, because what we are having in this bracket will give us -4. So -4 times 0 will give us 0. 0 is greater than or equal to 0. Is this statement true? Yes, the statement is true. We had 0 for this side, and it is 0 greater than or equal to 0, and that statement is true. So -1 is inclusive. We are testing this side, so let's pick another value there. So let's say -2. Once again, when x is equal to -2, what is going to happen? We take this same factorized expression here. So we have -2 plus 1. We have -2 minus 3 is greater than or equal to 0. Once again, let's analyze whether this statement is true. -2 plus 1 is going to give us -1. And we have -2 minus 3, and this side 2 is going to give us -5. Is greater than or equal to 0. Now, -1 times -5 is going to give us +5. So 5 is greater than or equal to 0. Once again, this statement, is it true? Yes, 5 is greater than 0. So the statement is true. This means that from -1 up to -infinity, all the values there, when you use them for the testing, it is going to be true. It is going to be valid. Therefore, from the -1 up to -infinity, all the values there is going to make this inequality statement here valid or true. Therefore, what inequality statement can we write for the range of values there? And that is going to be x less than or equal to -1, starting from the -1 up to -infinity. And this statement here defines all the values for this side. If that is the case, then the other side too is going to work for that. Anytime it's happening like this, anytime this side is valid, it means that this side too is going to be valid. And the middle part is going to be undefined. You can do the testing and check. Now for this side, when x is 3, let's do the checking. When x is 3, we are using the same factorized expression here. So we are going to have 3 plus 1. We have 3 minus 3 is greater than or equal to 0. 3 plus 1 will give us 4. We have 3 minus 3 will give us 0. Is greater than or equal to 0. Now ask yourself, 4 times 0, we are going to get what? 0. 0 is greater than or equal to 0. Is that statement true? Yes, the statement is true. The statement is true. So the 3 is true. You can pick any other value here. Let's say 4. You use that for the test, and that one too is going to be valid or true. If that is the case, from 3 up to positive infinity, how can we write the range of values there? Because all those range of values is going to make, or are going to make, this inequality true. Because we are moving from 3 up to positive infinity, the arrow is pointing toward this side. We are moving from 3 up to this side. Therefore, we are going to have our x being greater than or equal to the value that is here, 3. Always check the arrow where we are moving from and to. We are moving from this side up to this side. So the inequality, the tip, supposed to point toward this direction. That is the positive direction. Okay, so that is why we are using the greater than or equal to. So x is greater than or equal to. Therefore, our truth set is going to be x is such that x is less than or equal to -1. That is this defined values, or then this one too, x is greater than or equal to positive 3. So that is the truth set of the inequality, or the quadratic inequality above. That is the x squared minus 2x minus 3 being greater than or equal to 0 using the number line approach. Let's try another example. Let's try this example. Find the truth set find a truth set of the quadratic inequality 2x squared plus x minus 10 is greater than or equal to 0. Don't forget that this first type, we are considering the symbol greater than or equal to. Okay. So how can we find the truth set of this? Now the first thing we have to do is to check if this expression is factorable. If it is factorable, get the factors, or all that we have to do is, because it is quadratic expression, we want the two values. That is when we solve the two values that we are going to get. That is why we are factorizing this. You can use any different approach to solve and get the two values there. But we want to factorize, because when you factorize that, the factorized expression will make it easier for you. Okay. So we want to factorize this. Therefore, we are going to have 2x squared. Therefore, we are going to factorize this. So how do we factorize that? We take the constant, that is -10. We use that to multiply the coefficient of the x squared, that is 2. So this is going to give us -20. We find two numbers in which when you multiply, you get a -20. But when you add, you get a coefficient of the x term, that is +1. Because the coefficient of x is +1. So we can have 5 and then -4. Because this or these numbers will be the perfect number that will work, or that can satisfy this condition. So 5 times negative 4 is going to give us negative 20. 5 plus negative 4 is going to give us positive 1. So we are going to use the two numbers. Therefore, we are going to have 2x squared. So positive 5. Therefore, plus 5x minus 4x. Then we bring the last term. So minus 10 is greater than or equal to 0. We take the first two terms, we factorize. We take the next two terms, and then we factorize. When we take the first two terms, 2x squared plus 5x, the common factor there is x. So you have our x. You are going to be left with 2x plus 5. The next two terms, that is the minus 4x minus 10. The common factor there is minus 2. So we have minus 2. We are going to be left with 2x plus 5 greater than or equal to 0. So in this case, we are going to have our x minus 2 in one bracket. That is what we are having outside the bracket. So x and then a minus 2, you put that in one bracket. And then you have your 2x plus 5. Also in another bracket, being greater than or equal to 0. So what we have to do is solve for the two values there. We take each linear factor, we equate it to 0, and then we solve for the value. So we get x minus 2 is equal to 0. We have x to be equal to 2. We take the 2x plus 5 is equal to 0. We have 2x is equal to negative 5. And this will give us x being equal to minus 5 over 2. And that is what? Minus 2.5. So the two values that we had when we solve this quadratic expression was x being equal to 2 and x being equal to negative 2.5. Now we have the two values. So how do we find the true set of this particular quadratic inequality? Once again, let's use the graphical approach. The expression was 2x squared plus x minus 10 is greater than or equal to 0. And we had the two values to be equal to x being equal to 2 and then negative 2.5. Okay. Now my question is, what is going to be the nature or the shape of this particular quadratic expression? That is when we grab that. Don't forget that you can use the coefficient of the x squared to determine the shape. Now the coefficient of x squared is positive. It's positive 2. And as I said in the other example, that if the coefficient of x squared is positive, it means that the shape is going to be like this. Okay. So let's assume that this is our xy plane. Something like this. Okay. And then we have positive 2. This is not drawn to scale, so we assume that we have our 2 here. Then we have negative 2.5. Let's also assume that there's somewhere here. Okay. Because the curve is going to open up like this, the curve is going to pass through these 2 points. These 2 points. Okay. So we are going to have, this is not drawn to scale, so we are going to have something like this. Okay. All right. So now we have our curve to be like this. And once again, because the inequality sign in the quadratic inequality is greater than or equal to this particular sign, it means that shade the part of the curve which is above the x-axis. So we are going to have this. We are shading this part because this is above the x-axis. Now that you're having it in this form, trace it to the x-axis. So you're going to have something like this. And you can do this up to what? Positive infinity. Since you are shading from this side up to positive infinity, we are moving from the positive 2 up to positive infinity, so up to this side. Therefore, the positive 2 is inclusive. The x values on this axis, the positive 2 is inclusive. If that is the case, since we are moving to this direction, we are going to use this inequality symbol that is greater than. We bring the equal to there, or because the 2 is also inclusive. So we are going to have our x being greater than or equal to 2 for the side. You come to this side. This side 2 is part of the curve that is above the x-axis. So we shade. And you can shade this up to positive infinity, assuming that the curve is to be extended. Once again, trace it to the x-axis because the x values is what we are interested in. So you trace this to the x-axis so that we shading up toward negative infinity. So once again, we are moving up to this side, or we are moving in this direction. Since we are moving in this direction, the x values, the negative one, is also inclusive. So the direction is like this. You include the negative 2.5. So this inclusive symbol should come. Therefore, it's going to be x is less than or equal to the value that is here, that is negative 2.5. So if you want the truth set, this range of values will satisfy this inequality, this quadratic inequality. So this one and this one satisfy the inequality that is up there. Therefore, our truth set, we're going to have x is such that x is less than or equal to negative 2.5. That is this particular one. Or you come and pick this one. Also, x is greater than or equal to positive 2. We are bringing or because we have to add these two. We have to put them together. So we don't have to use the word and. We are finding the truth set. Or means union. That is why we are combining this one and this one. So that is why we are having the or there. If you bring the and, the word and, it means you are trying to find intersection. And that is no. Okay. So that is how we can find the true set of this particular quadratic inequality. Let's try and use the number line approach also. That is the testing approach. Okay, so for that one, for the testing approach, the quadratic expression given was 2x squared plus x minus 10 being greater than or equal to 0. When we solve for the quadratic equation or the expression, we had x equal to 2 and then negative 2.5. So what we are going to do is, let's draw our normal line, which is not drawn to scale. So assume that this is our number line. It is not drawn to scale. We have our 0 here. Let's say we have our positive 2 here. Then we have negative 2.5 also here. Now we have 3 main parts. You have to get the part. So you draw a vertical line to pass through these 2 values. So we have this line, we have this line, and this gives us the 3 parts. So we have this part, we have the middle part, then we have this part. Okay, so we are coming to test And don't forget that this particular quadratic expression, when we factorized, what did we get? We had x minus 2, and then we had 2x plus 5 being greater than or equal to 0. That was when we factorized this, or when we factorize, yes, we're going to get this particular expression. So we're going to use that to do the testing. We start with the negative 2.5. When x is equal to negative 2.5, what is going to happen? Now, when x is equal to negative 2.5, so we are going to have the negative 2.5 minus 2. We are going to have 2 multiplying the negative 2.5 plus 5. This is greater than or equal to 0. Now, in this bracket, 2 times negative 2.5 is going to give us negative 5, plus 5 is going to give us 0. So 0 times whatever value that we are going to get here is going to give us 0. Now the question is, 0 is greater than or equal to 0. Is this statement true? Yes, this statement is true. 0 is equal to 0. Alright. If that is the case, it means that this particular negative 2.5 here is making the inequality valid or defined. This quadratic inequality, this value, negative 2.5, is making it defined. Pick another value of your choice from the negative axis, this side. So let's say you can pick negative 3. So when x is negative 3, when x is negative 3, what is going to happen? Now negative 3, so we are going to have negative 3 minus 2. We have 2 multiplying negative 3 plus 5 is greater than or equal to 0. Let's analyze that. Negative 3 minus 2, that is going to give us negative 5. Inside this bracket, 2 times negative 3 will give us negative 6 plus 5, and that is going to give us negative 1. Is greater than or equal to 0. In this case, negative 5 times negative 1 is going to give us positive 5. So we have 5 being what? Greater than or equal to 0. And this statement too is true. It is defined. Okay. If that is the case, it means that the values from negative 2.5 inclusive up to negative infinity, all the values there, they are going to make the inequality expression here, this quadratic inequality, defined. So this side is what? Defined. Therefore, you writing inequality to define the range of values that are there. Because we are moving in this direction, the inequality sign is supposed to be this. Look at the tip. Don't forget, it's pointing toward this direction because we are moving to this direction. Okay, so if that is the case, then we are going to have our x being less than or equal to this particular value. Negative 2.5 is inclusive, so you have to bring the equal to sign. Therefore, x is less than or equal to the value that is there, and that is negative 2.5. And as I said, if this side is defined, then definitely this side too is going to be defined. You can do the testing to check. When x is equal to 2, what is going to happen? Now, when x is equal to 2, we are going to have, so we are using this factorized expression here. So 2 minus 2, we have 2 multiplying 2 plus 5 is greater than or equal to 0. Now 2 minus 2 is going to give us 0. What do we have in here? 2 times 2 is 4. 4 plus 5 is 9. This is greater than or equal to 0. Now 0 times 9 is going to give us what? We're going to get 0. So 0 is greater than or equal to 0, and this statement is true. So when x equals to 2, it's making the statement true. When pick any value of your choice here, let's say 3, do the testing and see. Or 4, or 5, or 6, or 10, do the testing and see. It's going to make the inequality or the quadratic inequality here defined. So it means that this side too is defined. So we are moving from positive 2 up to positive infinity. Therefore, the sign is going to be like this. The tip, don't forget, is pointing toward this side. That is why we are having it like this, from 2 up to positive infinity. So it will be x, and because 2 is inclusive, it's going to be x being greater than or equal to positive 2. Now, when you consider the middle term is going to make it undefined. You can try and check, or let's do the testing. When x is equal to 0, what is going to happen? When x is equal to 0, and the factorized expression was x minus 2, 2x plus 5, being greater than or equal to 0. So in this case, when x is 0, we are going to have 0 minus 2. We have 2 multiplying 0 plus 5 is greater than or equal to 0. Now 0 minus 2 is going to give us negative 2 times this 2 times 0 is going to give us 0. So 0 plus 5 is 5, being greater than or equal to 0. Now negative 2 times 5 is going to give us negative 10. So negative 10 is greater than or equal to 0. Let's analyze the statement. Negative 10 is greater than or equal to 0. This statement is false. Yes. So when we come back to our expression, realize that values within this side will make the inequality undefined. Undefined. Therefore, we ignore that because we are interested in the defined set of values, or the values that will make the statement true, and that is the truth set. Therefore, our truth set is going to be x is such that x is less than or equal to negative 2.5, or x is greater than or equal to positive 2. Now this brings us to the end of our lesson, but I want to give you a question. You try that for me. You can give me the solution of what you had by commenting on the video. Okay, so I want you to try this question. 6 minus 5x minus x squared is greater than or equal to 0. Okay, I want you to find the truth set of this particular question. Our next lesson, we are going to consider the inequality symbol, that is the greater than. So watch out for our next video. Thanks for your time.